All right, today we're going to peek under the hood of AI and look at the actual engines that make everything run, these super specialized chips called AI accelerators. Let's dive in.
And yeah, that really is the multi-billion-dollar question facing developers everywhere. See, the chip you choose, it's not just some minor technical detail. It literally defines the speed, the cost, and even what your AI can do. So how on earth do you pick the right one?
Right, and this is a problem you really have to solve up front. Because, look, making the wrong choice here isn't a small mistake. We're talking sluggish performance, totally blown budgets, or a system that just hits a wall and can't scale.
I mean, think about it. This one decision impacts literally everything. We're talking raw speed, the actual dollar amount on your cloud bill, and even the energy footprint of your AI models. The stakes are incredibly high.
Okay, so let's meet the three main contenders in the ring today. We've got the GPU, the TPU, and the brand new LPU. And each one has a completely different design philosophy.
First up, you've got the GPU, the graphics processing unit. Just think of it as the Swiss Army knife of AI. It was originally built for video games, sure, but its massive parallel processing power and this super mature software ecosystem, NVIDIA's CUDA, frameworks like PyTorch, have made it the absolute go-to workhorse for a crazy variety of AI tasks.
Next up is Google's TPU, or Tensor Processing Unit. This one is more like a specialized factory assembly line. It's what's called an ASIC, an application-specific integrated circuit, which is just a fancy way of saying it was designed for one single purpose, to just crunch through the massive matrix math that's at the very heart of deep learning. It is hyper-efficient for training huge models, especially if you're inside the Google Cloud ecosystem using tools like JAX or TensorFlow.
And finally, the newcomer on the block, the LPU, or Language Processing Unit from companies like Grok. Now this is your Formula One race car. It is meticulously engineered for one single mission, delivering language model responses with the lowest possible delay. We're talking about things like real-time chatbots, where every single millisecond counts. This thing is built to win that race.
So, those are the analogies, right? The big picture. But what does that actually mean in practice? How do these chips really differ under the hood? And more importantly, what does it mean for you? One of the biggest, most practical differences right off the bat is the ecosystem. GPUs are pretty much everywhere, and they support almost everything. In contrast, TPUs and LPUs are way more specialized. TPUs basically lock you into Google Cloud and its preferred frameworks, while LPUs are laser-focused on just the inference software. This can be a huge deciding factor before you even start looking at performance numbers.
Okay, so when you put them all side by side like this, the trade-offs get super clear. The GPU's general-purpose design makes it the most versatile. You can deploy it anywhere, from the edge to the cloud. The TPU, with its specialized systolic arrays, is an absolute beast for huge training jobs, but it's pretty much tethered to Google Cloud. And then there's the LPU, purpose-built for one job, real-time serving, and its entire ecosystem reflects that intense focus.
All right, this all leads to the big question, right? When do you actually use which one? Let's break it down with some real-world scenarios to make this crystal clear.
Let's say you're training a massive new model from the ground up. You've basically got two great options. GPUs are going to give you the ultimate flexibility with different frameworks and deployment options. But if you're all in on Google Cloud and you just want pure brute force scale for training, TPUs are an incredibly compelling choice.
Okay, different scenario. What if you're building a chatbot? You need it to feel instant, No awkward pauses while it thinks. In this case, there's no contest. The LPU is the undisputed champion. Its entire architecture is built to minimize that time to first token and deliver a super smooth conversational experience.
But let's be real. Modern AI is rarely just one thing, right? What if your app has to understand pictures and process text and maybe even generate audio? For these mixed or heterogeneous workloads, the GPU's Swiss Army knife versatility makes it the clear winner.
And finally, a super practical one. Where is this thing actually going to run? If you need it on your own servers, on premises, or on tiny devices out in the world, at the edge, well, GPUs just give you way more hardware and software options, period.
Okay, so to pull this all together, let's boil it down to a simple checklist, something you can actually use to make the right call for your own project.
All right, here's your framework. First, just define your workload. Are you mostly training or are you mostly running inference? Second, what do you care about more? That instant response time, that's latency, or just raw processing power, that's throughput. After that, check the ecosystem. Make sure your favorite tools are actually supported. Then, plan your deployment, cloud, on-prem, edge. And finally, please don't forget this. You can get huge gains just by optimizing your software with stuff like mixed precision and smart batching.
So let's do a super quick recap. Your key takeaways. GPUs, they're your flexible, do-it-all all-rounder. TPUs, an absolute powerhouse for huge training jobs, especially if you're on Google Cloud. And LPUs, they are purpose-built to make your language models feel lightning fast. But maybe the most important takeaway of all is this. Always, always try to optimize your software first. Smart code can save you a fortune on hardware.
And that kind of leaves us with this big, fascinating question for the future, doesn't it? We've gone from the general CPU to the GPU, and now to even more specialized things like TPUs and LPUs. So as AI keeps evolving, are we heading towards a future with a unique processor for every single task? Or will one single powerful architecture eventually emerge to rule them all? It's a space we'll be watching very, very closely. Thanks for tuning in.